So in this video, I'm going to share with you how we can use the HTML5 audio context to create this sort of audio visualizer. Some may refer to it as an audio spectrum or an audio waveform. So there are two ways we can go about it. So one of them, the first one is the very common one. If you go to MDN documentation on HTML5 audio context, you will see that. So in that example, you do something like this. The one that you find on MDN or official documentation page is something like this sort of animated visualization. Here is just what happens here is as the audio continues to play, you get the data for at that particular time, the frequency byte data at that particular time, and then you create this sort of effects. There are so many cool stuff that you can do with that, but I'm not talking about that one. The one I'm talking about is the one we have here, okay, in this what's called wavesurfer.js. So here, each of these vertical bars represents a second in that audio clip. So the first is 0 second, the second one, the first second, and so on and so forth. So let's start with getting that data and how we can use it. In my HTML, in these little, should I call it projects that we have here, I would, so I have this empty HTML page. So I'll create a canvas element. So that is where I'm going to draw it on, draw these visualization stuff on. Let me just give it, I'll give it a width of 1000 and a height of, let's see, 200, okay? And then let me give it an idea of canvas. So so we have our main.js file here. I'm going to attach that. So the first thing we have to do is to load. We need to have the audio, the full audio data. So this is kind of a disadvantage to this other way of doing it. So we need to have load the full audio data, get all data from that audio, and then we represent it on our canvas. So let me first of all just say you are okay. Let me name a variable for that so that I just so that we can change the audio file. So if we add an audio file, we can just switch it up. So we're going to first of all load this. We're going to use the fetch API. Then when we get the response, we're going to return it as an array buffer. Okay. And then the data that we get, the array buffer data that we get. Sorry, I'm still new to this keyboard. Array buffer data that we get, we're going to let's create a function called decode. So we need to have this data. So after getting this data, or not decode URL, decode. So after getting this data, I'm going to make a little sort of explanation. Now we're going to have our data. Then let's create a function decode. Decode is going to be asynchronous because there's going to be one of the functions there is going to return a promise. So it's going to take data. So the first thing the code is going to do, we're going to create a new audio context. And then, oh, sorry. and then we'll call we're going to get the audio buffer object. So the code audio data. This is supposed to be asynchronous because these returns we are supposed to await this, sorry, because it returns a promise. I don't know why my keys keep jumping. Oh, so we'll just log the audio data, sorry, audio buffer objects, and there are a few things that I will just want to explain briefly. Then come here. Let's open this with our live server. So let's inspect our browser console. There's an error. No, there's no error. Why? What happened? Oh, sorry, there's an console.log. This is bullshit, man. So when we do that, we have our audio buffer objects. So there are a few properties that I would like you to pay attention to here. The first one is the number of channels. So what we need to draw this kind of waveform that I'm talking about is the audio data. I'm going to show how we get it. Just a tree function. We can get a tree function here. Now, most music are recorded in stereo sound. So for this number of channel, you most likely going to find a value of 2 for most audio that you're going to work with, for most audio files that you're going to work with. So it's not a constant, okay? It's just the number of channels, and most music, they are recorded, most stereo sounds, they are recorded in double channel, the right and left channels. Just know that. So we are just going to get the channel, well, we're going to get the audio for one channel and use it to represent. You can use the first or the second channel. So I'm going to use the first channel in this case. Another thing is the sample rate. So what exactly is a sample? This little diagram explains it. So the process of converting an analog audio sound, which is exactly what you're going to get, to its digital form, is more like what sampling is. So what we do is we use discrete values to represent each point in this changing amplitude. I'm referring to this as sinusoidal curve here. Okay, so the sample rate is the number of these individual points that we collect in every second. The value that you find here is, you will most likely see this 44100 as a value, which translates to 41.1 kilohertz. It's more like a standard for recording music. So don't be surprised if you see something like a 48100 here or something even higher. But just like the number of channels, you most likely going to find this value here. But no, it's not a constant. So you always have to just put that back of your mind that it's not a constant. Okay. So it represents each, so the total number of these discrete values that we are getting for these continuous signal in an interval of 1 second, it's known as the sample rate. So there are a few ways that we can go about doing this. So the first is, maybe we get the number of, we get the average of the samples for every second. We get an average of the samples for every second, and then we plot that value on our canvas. So we render that value on our canvas. Or another thing is, we can do something, we can use the dynamic range within an interval of 1 second. within every interval of 1 second. That's the difference between the lowest value, the lowest point, which is usually the trough, in a way, for those of you who do the trough, and the, I think the crest. Is it crest? I forgot the name. So what it means that the highest points and the lowest difference between the highest points, that the highest sample and the lowest sample, is actually dynamic range. So we can use that to represent every second of that audio clip, or we can use an average. Try the first. Let's use an average. Use the average to represent. I'll call it get average. So get average is just it will require an array. Mm. It has an array, a start, and then an end. So I don't want to duplicate, because so first of all, I forgot to do something. Okay, I'll do that. So it will have a start and an end, and then let me just add another value. Let me call it a scale. I'll tell you the reason for this scale. I'll give the reason for this. So we are not going to log this audio file. Let's get the data. Let's first of all get the data for each uh, for the first channel data. So we do that by saying const audio data equals. So get channel data, will pass the value of 0, which represents the first data. We can also just, yeah, let me just log the audio data, because yes, little thing that I want to talk about here. Audio data. So the audio data, like you see, is a float 32 array. So it's a JavaScript typed array. Okay, just also know that. And there is another thing. The audio data that you're going to get here is going to be it's in a normalized form. That is, it is between uh it's not higher than 1. So in this case, it's between -1 and 1. Okay. It's not going to fall. It's not going to go beyond it. And the reason for this is, if you've worked with vectors, or even in machine learning, or anything that uh, let me say vectors, for instance, most operations that you see, if you're going to use a library or that does some sort of operations, most operations, you're going to see they are going to return values or return results in a normalized form. That is between 0 and 1. The reason for this is for reusability. So you just have to scale. So if I have a scale of maybe I want to do the vector the vector I'm going to work on is between the range of 0 and 1000. I just have to multiply by 1000 the value I get from that vector operation. Okay, so we are just it's that is how so what we have here is just the normalized form, and that's why we're adding this other value called scale, because we are very sure that the value I'm going to get from this audio data is between -1 and 1, falls within that range. Uh, so what get average, what is it going to do here? So get average is going to loop through this data starting from the start. So uh, I is equal to start. Mhm. And then let's define the value. Let 0. Plus 2. And then at the end, we're going to return uh, value times the scale. That's what we are going to return. So let's create a global variable. Note, this is just a tutorial, so I'm not applying any sort of design pattern. If you want to go, if you're going to do something like this, you can either make it a web component or a component for your favorite library. Like in the case of Angular, maybe an Angular component or a React component or whatever, however you want to do it. So this is just a tutorial, so there's no emphasis on design pattern, even approach. Let me just call this analyzer. Oh, it's going to be an empty array. Another point to note is optimization. If really I'm going to use this in a production environment, I'm going to use a typed array, a JavaScript type array, and an array buffer to do this. I'm not going to use a normal array, but since it's a tutorial and it's meant for anyone, whether new to JavaScript or anyone, just about anyone, I'm trying to make it as easy as possible, but I'm not going to do this in a production environment. I'm going to use a typed array. So also note that. So let's go. Now, I talked about the what's it called, the sample rates in audio from our audio buffer. So if we divide the sample rates by if like if we divide the sample rates, sorry, if we divide the data, the total number of data, okay, the length of the data, the audio data by the sample rate, we are going to get the duration of that audio. It's something similar to a frame rate. So if you have a video of 24 frames per, or let me say 30 frames per second, and the total number of frames after you've done your frame extraction on that video is 90 frames. If you divide 90 by 30, you're going to get 3. It means that the duration of that video is 3 seconds. So something where it's something similar. The sample is something similar to frame rate. Okay. Although in a video it's 3-dimensional, it's 2-dimensional here, but they are similar. I'm not saying they are the same thing, please. So we can just, okay, let's do it this way. Let's use the duration. Let's get the duration of this audio. Custom. We are going to loop through the data with the duration, and in each and in each iteration, for each iteration, we're going to add the sample rate. Okay, so for okay, first of all, let's get length. Okay, we have to floor it because this is going to give a float value. Dot floor right here. So also let's get the sample rate. We are going to add the sample rates. We are not going to increase the index by 1. We are increasing the index by the sample rates. Okay. So this is the data. This analyzer that we define here is the data we are going to use to create our visualization. So we are going to push the average of all the samples for each second into this particular array. Get average. Let's get our average. So we're going to get the average. We'll pass in our audio data. The start index will be the current value of I, and then the end will be I, plus the sample rate. And then let us use a scale of 200 since our canvas, the height of our canvas is 200. Okay, so that's what we're going to do here. We are getting the average and then we are pushing it there. So by this, we have our value for our analyzer. So this what it is with the value that we are getting here that we are going to draw on our canvas. So first of all, let's get a reference to our canvas as well. Oh, element for ID. Sure, I used canvas there. Uh, let's get the canvas drawing contest. So we'll call the function. Let's call the function draw. So in fact, with the audio data, I can even stop the so with the audio data, I can even stop the tutorial here. But let's just go further ahead. So we have our audio data. Let's log the audio data. Analyzer. Okay. Yeah, I forgot to do something. Why is it war? It's not supposed to be war. Oh. It's supposed to be the length of the audio data. So sorry. The length here is not supposed to be the duration. So we are going to divide sorry, we're going to divide the length of the audio data. Audio. In fact, we don't need anything with the duration. We're just going to audio data dot length divide. We're going to divide it by what is it called? The sample rate. Okay, and then that is going to give us the duration, like I explained before. Let's floor it, right? Yeah. So I'm going to floor that. That is going to be the value of our length. Yes. Sorry. Cool. Why is it showing only one? It's supposed to be more than that. Is this thing saving? Yeah. Audio data dot length. Yes. Divide by the sample rate. What am I doing? It's not supposed to be so. It's supposed to be uh so it's supposed to be so this is going to give us uh the whole number for the length. So let me just say, let's multiply this value times sample rate. Okay, so this is going to give us the duration. So this is going to give us the duration. We have to multiply this value here, and now we have the data that we need. Just to be sure what I'm doing here, so I'm dividing the audio data, the length of the audio data, by the sample rates. I'm getting the value in whole numbers because we want a value that is a multiple of the sample rates. That's what we want. We want a value that is a multiple of the sample rates so that we don't have an error in this function, okay? Or we don't have some undesired result like not in number. And then we are going to loop, and in each iteration, we are going to add the sample rates to this value. Okay, just to be clear on that. So we have the value, the data that we need. So the next thing is to draw the data, on our canvas. So we have our canvas, our drawing contest here. So let's first of all, so we are going to create some values. Let me call it bar width. Okay, the width of each of the vertical bars. That is going to be, I'll have to get data. Okay, that's going to be the width of the canvas. Okay, canvas dot width divided by the length of the data. What's wrong with me? We don't need this data. We already defined it as a global variable here, this analyzer. So it's going to be dot. That's going to be the bar, the width of each of the bars. And then we first of all clear the rectangle before we do any drawing. We don't need it now because we are going to do it once, but okay, let's just go. So canvas dot fill. So there are two variables we are going to use. Let's also initialize on that variable. Let's call this one x. The x position is going to change. We are moving from left to right. 0. We are going to increment x by the width of the bar. Okay. So we are going to fill our rectangle. Hope this content fill rect. So the x will be the value of our x. The y in this case would be canvas dot minus the height of that bar. So analyzer I, right? And then the width, of course, would be the bar width, and then the height would be, of course, the data there, the value at that point. Let me wrap this. Get it so long now. Okay. That's what we are going to do. I think that is that. If we save, if there are no errors, we should see some bad. Okay, no. So after we've gotten our analyzer, called the draw function, draw on the canvas. Oh, it seems to be like there is an error. Okay, it seems to be drawing, but there's an issue here. You can see there seems to be an issue here. Wait, are we passing the scale? Oh, sorry. It's supposed to be, we are supposed to get the absolute value. Supposed to get the absolute value here. Absolute value of, sorry, because it's either negative or positive. Okay. Yeah. So we have our data. This is the data. This is this for every second. So what we are doing here, we are using the average. We are getting the average for all the samples for every second, and then we are just drawing it here. I think this is just exactly what you need for the tutorial. You can go on I don't think you need to watch any other thing in this tutorial. But yeah, this is exactly what we need. We can decide to add we can decide to maybe uh add a gap. Okay. If we decide to add a gap, then maybe gap, we can decide to add a gap like in wavesurfer here. There's a little bit of gap with it. Okay. So let's add a gap. To add a gap, what we do here, I will no longer call this bar width, I'll call this span. Okay. Um, then the bar width will be span minus, okay. So if we have two bars, there's going to be one space. If we have three bars, two space, and so on. So it's going to be called space. So it's a tutorial, so no design part. Let me call this a gap equals to 0. Span with gap. Let's use a gap of 2 or 3. Let me say 2. It will be span minus oh, the gap of 2, right? So analyzer dot wait. There's a little mistake here. So the total number of gaps will be the total number of gaps that we are going to have will be bar width to be span minus uh, the total gaps that we are going to have. Total gaps will be analyzer dot length minus 1. Okay, for three gaps, for 3 bars, we are going to have 2 bars, so forth. We are now going to divide this by all the gaps. Mm. This dey happen. Analyzer dot length divided by 2. So the total number of it will be this, I would say, gap. This will be the total number of gaps we are going to get. Okay, this will be the total number of gaps we are going to get. We are going to divide it I'm going to divide this by the analyze at the length of the we are going to divide by all the powers here. So this will be the power width. And then when we are increasing by the span. Okay. Yeah. So now we have this. You can see that we have the gap there till the end. Okay. Yeah. So that's it for this is how we can recreate that. The good thing about this is we can define how we want it to be. We can, we can make it aligned. Like here is central aligned. So I tried this wavesurfer, something like this. I've tried this wavesurfer. Okay, try this wavesurfer, and then I found out that it's you can't. I couldn't immediately. I don't know if it's possible. I couldn't align it to the bottom like we have here in our own tutorial. So that may be a reason you ignore wavesurfer and create something. And aside that, there are other effects that you can create. So I don't want this tutorial is definitely too long now. I don't want it to be very long. I would actually want to create a full audio experience. So it depends on the response to this video. If you like this video, uh, if so the tutorial is definitely going. It's definitely too long now, but I would like to if you want something, I would prefer to create like a full audio experience, something where you can click, or as the audio starts continues to play, you can be increasing the bar. But I will make it like, let me just I can do it as a part two of another video. If it depends on the response to this video. If you like it and just want me to create the full audio experience, then I'll do it. Uh, thank you. The total number of it will be this, I would say, gap. This will be the total number of gaps we are going to get. Okay, this will be the total number of gaps we are going to get. We are going to divide it. We are going to divide this by the analyze at the length of the we are going to divide by all the powers here. So this will be the power width. And then when we are increasing by the span. Okay. Yeah. So now we have this. You can see that we have the gap there till the end. Okay. Yeah. So that was it for this is how we can recreate that. The good thing about this is we can define how we want it to be. We can, we can make it aligned. Like here is central aligned. So I tried this wavesurfer, something like this. I've tried this wavesurfer. Okay, try this wavesurfer, and then I found out that it's you can't. I couldn't immediately. I don't know if it's possible. I couldn't align it to the bottom like we have here in our own tutorial. So that may be a reason you ignore wavesurfer and create something. And aside that, there are other effects that you can create. It's definitely too long now, but I would like to if you want something, I would prefer to create like a full audio experience, something where you can click, or as the audio starts continues to play, you can be increasing the bar. But I will make it like, let me just I can do it as a part two of another video. If it depends on the response to this video. If you like it and just want me to create the full audio experience, then I'll do it. Uh, thank you.